Welcome to Extra Class Online Academy, your #1 hub for free quality education, anytime, anywhere. We offer a wide range of online lessons covering ZIMSEC subjects from Form 1 to Form 6, Cambridge IGCSE, South African Matric from grade 10 to 12, and many other valuable courses to help you succeed academically and beyond. Whether you're preparing for exams, catching up on classwork, or learning something new, we've got you covered, and the best part? It's all absolutely free, no matter where you are, in Zimbabwe, South Africa, or across the world. Education should be accessible to everyone. At Extra Class, we believe in learning without limits. So go ahead, subscribe, explore our lessons, and join thousands of learners already upgrading their knowledge the smart way. Let's grow together. Extra Class Online Academy, learn free. Learn smart. Learn anytime.
The weather station. A weather station is a place for making weather observations, weather forecasting, and providing people with weather information. So these are the three basic uses of a weather station. Schools, farmers, airports, harbors, and parks, and many other departments have weather stations. This is primarily because they need weather observations. They also need to be able to make forecasting and get weather information. Weather stations need to be appropriately located for accurate measurements to be taken. So what you are looking at here is a typical weather station where we have got various components, and all these components are for taking various weather information. For instance, you can see this cup anemometer, a Stevenson screen, and a evaporation dish or tank, and many other instruments. So weather stations should be located in appropriate places. Why? We want to look at the reasons why this weather station should be in an appropriate place. The primary reason for this is because the weather instruments must record the weather elements without disturbances. So they don't need any disturbance from things like trees or buildings or animals that can pass by. So it must be located in a appropriate place and well secured. Sunshine recorders. This is one of the instruments that we have studied about. Need not to be where they are not obscured by objects. So a sunshine recorder is an instrument that doesn't need to be obscured from receiving sunlight. Otherwise, it will not work correctly. The cup anemometers, those ones to measure wind speed, need to be in a place where the wind can blow freely from any direction. These instruments must be able to record the elements freely. The best location for a weather station is a place where there is gentle sloping ground. This will allow for proper runoff. Where there are no tall trees, because trees will cause a shadow which will disturb all the instruments. The grass must be kept short, yes, because grass sometimes it can reduce the speed of wind at ground level, so it must be kept short. It should be away from buildings. Those buildings, number one, they change the direction of wind. They also reduce the speed of wind. They cast shadows. There should be no artificial surfaces. This means A weather station must not have no concrete surface. Why? Why is it we don't put a concrete surface at a weather station? The primary reason is those artificial surfaces, they alter the temperature around. They change the temperature. Where there are no walls, this is because wind and other elements must be able to blow freely. Lastly, there are no roof. Yes, we don't put a roof above our weather station because a roof is going to alter the weather elements and then it will give us incorrect information. The weather station should be fenced and the gate should be locked to prevent disturbances from wild animals and livestock, and also to prevent unauthorized people from tampering with the instruments. So the fence must be high, the gate must always be locked. So at the weather station, we find all the weather instruments that we've discussed about, any of those that are available at that weather station. And these instruments are, the small ones are kept in a device called a Stevenson screen. So let us turn our attention now to the Stevenson screen. A Stevenson screen is a shelter for weather instruments. So what is this Stevenson screen? It is a white box, or it is a wooden box which is painted white with louvered sides, where some small instruments such as the maximum and minimum thermometers, the barometer and hygrometer are put. So what are the characteristics of a Stevenson screen? These include the following. A Stevenson screen is painted white because it must reflect heat. Heat comes from the sun. So as you can see here, our Stevenson screen is painted white. It has got louvered sides to allow the free circulation of air inside the box. So air must be allowed to flow freely inside the box. That's why the sides are louvered. It is put on a stand of about 1.2 meters to prevent measuring ground heat. Remember, we have got our thermometers inside, so the thermometers must not measure ground heat, but measure the heat of the air, or the air temperature. Its doors should face southwards. If you are in the southern hemisphere, like here in the SADC region, the doors should face south. If you are in the northern part of the world, doors should face the northern hemisphere. This is to prevent directly facing the sun. It must not face, or the doors must not face the sun directly. It should have a double insulated roof. This is to keep the inside cool. Otherwise, the roof might cause a temperature rise inside the Stevenson screen and give inappropriate recordings. The walls are made up of wood or any other poor heat absorber. So the sides of a Stevenson screen are made with wood, or it is actually made of wood. The two roof layers are separated by an airspace to maintain cool temperature inside. So it's like a vacuum effect, where can you see here we have this part of the roof and we also have this part. this is the area where wind can pass through without causing any incorrect temperature readings inside. Or on this one, we have this space which allows for free circulation of air. Weather tables and graphs. So after recording the weather information, we now have the data. So to present this data, we use tables and graphs. Recordings for temperature, rainfall, wind speed, and all the other elements can be shown using tables and graphs. Like in this case, you are looking at a temperature reading from Monday to Sunday at a certain weather station. So here is the maximum temperature, here is the minimum temperature as recorded. So the data shown on a table can be used to produce a graph, and there are different types of graphs, but the most common graph used in weather data is a simple bar graph. So a simple bar graph simply shows the variations in temperature using bars of the same width. The length of the bars, however, varies according to the quantities shown. So this data that you are looking at in this table can be represented or can be shown on a simple bar graph as this. So this is the max, this is the minimum, right? And then here are our days of the week. Then here's the temperature reading going upwards. So now we have got only 7 days, and we can also see 7 dots on our graph. So this is a line graph which is showing the maximum and minimum temperature. The temperature rainfall graphs or climatograph, we can represent temperature and rainfall information on a graph where all the data given will be represented on a single graph. This graph will show temperature and rainfall at the same time. Like in this part, we have got rainfall information on this side, we have got temperature on this side, we have got our months on this side. So you can see from January to December, here is the rainfall recorded in green. Then here's the temperature recorded in red. So we are able to utilize graphs like these ones to show very important information. In this way, it is representing information about rainfall and temperature. And we can see that during the month of April to October, from this time, the temperature was rising and rainfall was going down. So it was getting hot, and the rainfall received was also getting low and low and low, while the temperature was going high, high, high. So this information now is used to make decisions for farmers, for meteorologists, for anyone who is interested in this kind of information. All right, we also have got what is called synoptic charts. So these charts give a summary of the weather situation at a given area and a time. They give us information on elements such as wind speed, wind direction, and cloud cover. These charts, they use symbols. The symbols are used to show the weather condition. Here are some of the symbols that are used. You are required to get familiar with these symbols. And otherwise, when you are reading weather maps, you will see these symbols used quite oftenly. So you have to Get yourself familiar with these symbols, and you must know what these symbols mean. For example, here is our map which shows the weather elements at a certain place. So on this chart, we can read quite a lot of information, and this information is represented in the form of symbols. Now, that's why you need to get yourself acquainted with these symbols. Otherwise, you get stuck and you never know what kind of information is being represented here. So get yourself acquainted. You need to know the symbols so that you can read these maps clearly. Areas of low pressure are marked with an L, and areas of high pressure are marked with H. So L on these maps represents low pressure, while H represents a high pressure. Areas of low pressure have pressure enclosed at the center, while areas of high pressure have high pressure enclosed at the center. Areas of the same elements on the weather condition on a map are joined using iso lines. So it's called iso lines. But there are other types of iso lines, and these include isotherms. What are isotherms? These are lines that represent points of equal mean temperature. So mean is another word for average. So equal average temperatures. Isohells, these are lines representing points receiving equal amount of sunshine. Isohumes, these are lines representing points of equal humidity. Isohets, these are lines representing points of equal precipitation. Isolents, these are lines representing points of equal amount of cloud cover. Isotherms, these are lines representing point of equal summer temperature. And lastly, isotherms, lines representing points of equal temperatures. So those lines that you see like this on the map, they are not just there for fun or to show you something. They give us very important information. Like in this case, if this L is representing low pressure,